Okay, so why Farmer John put the layer of dead leaves? So you mentioned a few important things. Okay, the first one is decompose. Alright, so the dead leaves will decompose and become nutrients for the plant.
Fertilizer instead of nutrients.
Fertilizer can, but do you say they decompose?
Yeah.
Can. Very good. Okay, must say they decompose and become nutrients or fertilizers for the plant. Okay, very straightforward. Next, any question here? No? Can see? Zoom in. Right, so they decompose, become nutrients for the plant. Right, you can talk about decompose. They become nutrients in the soil, and then the plant can absorb, reabsorb the nutrients back. Right. Okay. Next one. Okay, how global warming affects the area of ice covering the Arctic region from 1979 to 2010. Yuki? How global warming affects the area of ice covering? What happened to the area covered by ice according to the graph? Melt. No, what happened to the area? Decrease, right? You can see the area decrease, right? So based on the graph, explain how global warming. You have to explain how does global warming decrease the area of ice?
So is it like relationship?
Yes. How did it decrease? So of course you start with the global warming. Okay, what's this global warming about? Global warming. What does it do? What does it trap? Traps up heat in the Earth's atmosphere, and then what happens? It traps heat in the Earth's atmosphere, and then what happens to the temperature? Yeah, temperature increases, and what happens to the Arctic ice? Yeah, the Arctic ice melts, and hence the area decreases. Right? So you can see this is a complete answer. Why? Because sorry? Why is what? No, it's not cancer, it's the line. You see, because eventually, you see here, they ask you about how global warming affects the area of ice. They never tell you what happened to the area of ice, correct? So you're supposed to say what happened. The area of ice actually decreased. So eventually your answer, you must say how come the area decreased? Because global warming traps heat in the Earth's atmosphere, then the temperature increased, and therefore ice melt, and therefore the area decreased. Okay, you can see the flow. You must continuously flow in this way. Now, a lot of answers, a lot of students will just say that, oh, the area decreased. Global warming caused the area to decrease, or global warming caused the ice to melt. That's it, right? You may not get maximum marks if you just write that way. Okay, so it has to be in sequence. Okay, what's going on? That's it. You have to talk about what's going on step by step, right? Step by step, what's going on? Okay, then next. Okay, so name the gas in our atmosphere that is the main contributor of global warming.
Carbon dioxide.
Oh yes, carbon dioxide. Okay, how it causes global warming? So we write carbon dioxide. How does carbon dioxide causes global warming, Alisa?
When carbon dioxide is released into the air, the air becomes warmer, thus the heat will melt the ice in the Arctic region.
But how does it cause global warming? It never asks us how come the ice will melt.
Because the surrounding temperature increases.
Okay, but what does the carbon dioxide do? Yes, very good. Okay, carbon dioxide is the gas that traps the heat, right? So we say that the carbon dioxide, name the gas. So carbon dioxide is a gas. How it causes global warming? So we say that carbon dioxide in the atmosphere traps heat and causes the temperature, which causes the temperature to increase. Okay, quite straightforward because here they're just testing you. Do you know which gas is the one that traps heat? It's the carbon dioxide. Okay, it's not the oxygen, it's not the nitrogen, right? It's the carbon dioxide, the one that traps the heat. Okay. So far so good, huh? Right? Any other question? No? Very good. Everyone is very well behaved today. Okay, I like it the way it is. Huh? If every lesson can be like this, it would be best. I can say more jokes. Okay, continue. Right, so we have a monk seal. So based on the information, how global warming causes the population size of monk seals to decrease. So you have to read the story, right? The paragraph at the top. Xing Yao, can you give us your answer? How come global warming causes? Based on the story, you have to read the story. Why is it that the population is decreasing? Based on the story. Global warming, what does it do? Yeah. The what? The who? The young cannot take the heat? No. Okay, wait. So global warming, sea level rise, and then what happened?
Then the shores will flood.
The who? What?
Shores.
Okay, shores flooded. Now the shores and the caves, right? You mentioned something about caves, right? What are they? They are location for? To give birth, correct? So once they are flooded, they have no more land to give birth, so therefore cannot reproduce. Can, right? And therefore population decrease. Okay? You see that? So we will say that global warming increases the temperature. Temperature. The temperature on Earth and ice melts, which increases the water level that floods the places where the seal reproduce. Right, I know it's 1 mark, but there's actually a lot to explain. Yes. Right, it's quite long. What? What the? Population. Okay. Population decrease. Okay? Right? Monk seal.
Okay.
Yeah. What would you say? causing the shore and the sea to flood and submerge. Yeah, this provide less areas for monks to live those they are young. Can. Okay, the idea is there, right? Yes.
Can I write the sea tides will rise due to global warming,
Yeah.
making it difficult for the monsoons to find a dry and desolate space in the shore to rest,
Yes.
give birth and nurse their young.
Yeah.
Thus the population size will decrease.
Yeah, can. Same idea. Any others? But so far, okay, right? Y'all get like the question, right? Y'all will be like saying something else. You know what I mean? Why? Because I experienced already. You are now experienced P6, PSLE takers. Right? Do more, right? So if you do more, then you become even more experienced. All these become very obvious to you. All the answers is like, obviously it's like this, right? It cannot be something else. Okay? Next. Oh, next section. Okay, we'll keep going, right? Okay, okay, so we have a machine here. Now this thing has got magnets inside here. So it separates the what do you call that? Balls, the pellets.
Material.
The material. Okay, so it separates the materials into two containers. How does it do that? With magnets. Okay, so the clue here is with magnets. Now I can't tell which one they're pointing to, X and Y. Okay, so obviously the one here, the one at the container Q, must be magnetic material. You understand? And then the one over here must be non-magnetic material. Right, so what is the property of X and Y? So perhaps we can just say that one is a magnetic material, the other is a non-magnetic material, right? So it's magnetic material, then the other one is non-magnetic.
So you combine it.
Why? Which one is X?
X is the what? X is the white color one.
Is it?
And then Y is the black color one.
I can't tell. Never mind. Non. Oops. Okay. Can. Yes, go ahead. Okay, so how material Y was collected in container Q? How material Y was collected in container Q? Richter, can you help us with this?
Material Y will be attracted by the roller with magnets.
Uh-huh.
There's no magnets below the material Y will drop into container Q.
Okay. So material Y is attracted to the magnet at the roller, right? What? When the magnet is absent, it will drop down into container Q. Okay? Right, so it's about magnetic attraction. So that's straightforward. Okay? Have you all done this? Yes? Okay. Next. So can we go like a bit faster? Next one. Okay, Jonah, so why the hot drink in A is likely to cool down faster?
Because A is made out of metal,
Yeah.
thus and is a good conductor of heat.
Yeah, good.
Thus it will conduct heat away from the hot drink.
Okay, there's something missing. But your answer is correct. It is mark A. Mark A is made of metal.
I never thought about mark B.
which is whoa, are you okay? What happened? Are you okay? Are you trying to get something? I don't know. I thought you fainted or something. You know? Go and see what's going on. Okay, come. So mine is made of metal, which is a good conductor of heat and allows heat to be lost quickly to surrounding. Okay, so the key thing here is about losing heat. Right, it's a good conductor, so you must say that it lose heat. It lose heat. Is that right? Good conductor, so must lose heat faster than the others, and therefore the temperature, therefore it cools down more quickly. Right. So next one, C is made from the same material. Why C is likely to keep the drink warmer? Okay, C is the same material, which is metal. How come it keeps the drink warmer? Right. Ready? Okay, let's take a look at C. Now, what's the difference between A and C? Ah, yeah. Okay, so there's air. So what does the air do? It's a it's a poor conductor of heat, right? So you say that there is a layer of air. Okay, so mark C has a layer of air in between which X, S, and S. Okay, since air is a poor conductor of heat, less heat will be lost. And hence, yeah, so it's a poor conductor of heat. So less heat loss, and hence it is the contents are warmer.
Can I mark B is made entirely out of plastic, but mark C as air in between the walls of the mark.
But you must
air is a poor conductor of heat,
yes.
Yes,
can. Right? So the idea here is you must identify the air. You must say there is air in between. Poor conductor of heat, lose heat slower. Therefore, content become warmer. Okay? Yeah. Alright. So very standard, right? All the answers. Okay, next. So based on your answer, how do builders keep houses warm in cold country? Monisha? How do you think builders keep houses warm in cold countries? Based on your answer. That means based on our answer. What do the builders do? What can the builders do? Of air, yeah, where in the walls, right? So builders. What?
Just say they build houses with air spaces.
Every house got air space. Which house don't have air space? You know what I mean? Right? So builders in cold countries build houses with walls that has got air spaces in between. Right? So your air space has got to be in between the walls. The walls in between, right, has got air space. To prevent heat loss. Heat loss. LOSS or LST? T. Why?
It's S.
Heat loss.
It's S.
Okay. That has got air space to prevent heat loss. And hence keeps it warm. Okay? So easy. So you see, the more question you do, the better you are at
And you also get
analyzing, right? So nowadays, you see the question, they already know what they're asking for, right? They're asking about this thing, right? So you make sure you have the answer there, right? Then, so the only way for you to be able to have this ability is you must do a lot of these questions, okay? And that's why we go through so many of them, right? Eventually closer to PSLE, right? We have all these answers with good speed answering, right? You just keep flashing, 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 and then you put aside. Okay. Okay, next one. Lighthouse. Okay, each boat makes a shadow. Draw a cross on the diagram to show where the shadow of boat C will be. Elisa, where's the cross? Where do you think the cross is? In the water. Which part? Where?
between C and D.
Yeah, between.
Oh, really?
Here, okay? Put a cross there. Between C and D. The shadow will be over there. Okay, why the shadow forms there? Huh? No, it's not D. It's between. Now, these are all the different shapes. Different shape. So, where will it form? It will form between C and D. So, the question is why does it form between C and D? Okay, so it's about the properties of light. Okay, what's the property of light?
Light travels in a curve. Light travels in a straight line.
Light travels in a straight line, and what else? Can it pass through?
When an opaque object
Correct. Okay. Yeah, no, I hear the keyword, the opaque object, right? So light travels in a straight line, and the opaque, and it cannot pass through opaque object. Okay, so we write down light travels in a straight line and does not and cannot pass through opaque object. Hence, boat C, as can be seen when boat C blocks the line. Stop. Right? So the idea is about travel straight line, block opaque object, blocks the light. Okay, so the captain of boat A claimed that the light from lighthouse is brightest on his boat. How can you determine that claim? Anyone? Yuki? How can you tell that this captain of boat A is correct?
he's always wrong.
Why?
He's sharp.
He's what?
Huh?
What do you say?
Huh?
Okay, how do?
He's nearest to the light.
No, he said he's nearest to the light source, therefore it is always the brightest. Okay, now they're not asking you whether is he right or wrong. They're asking you how can you check?
You cannot.
How to check? What can you do? Come, Yuki.
You can use science.
Yuki. How to check? Yuki.
Measure the light density.
Measure. How to measure?
Count the number of lights.
Count the number of light. Okay. Yes, you're right. It's just to measure the light intensity. How? Use a sensor. Okay. They never say exactly what instrument. You don't need to know what
I put
instrument.
a totally different answer.
Yeah. What did you say?
I put see the darkness of his boat's shadow.
See the darkness. Cannot be. No.
Why cannot?
No. It's not the darkness. Right. So use
There
a
is so much
light sensor to check if the light intensity is the highest at its location versus the rest. Okay, that's it.
And I use compared to the rest.
Yeah, compared to the rest. Right, very straightforward. We'll finish this, right? Before we go for a short break. Finish the whole thing.
Huh? Finish the whole thing?
Yeah. Why since I was so well behaved, I might as well finish the whole thing. If not, after the break, all run around already. Ah. When you have more sugar in your body, you know, I don't know what y'all do during the break, right? Eat stuff, drink things, then all the sugar go into the head, then very hard to control one, right? Okay, let's continue.
Just do one more question, got 4 more.
Yeah, we'll do 4 more. Thanks for telling me, right? Come, let's continue. Okay, next 41. So this is a experiment here. They're trying to obtain clean water. Now, how does this thing obtain clean water? You see, they have heat over here, so the water will evaporate. The water, when it evaporates, become a gas. You pass through this thing, will condense, become water, and drop down. Okay, so that's how it becomes pure. Right. So based on the setup, identify the 2 different processes involved. Yeah, I already said that, right? So evaporation and the next one is condensation. Okay, evaporation and condensation. In secondary school, you will do this experiment, right? In the science lab, you'll be doing this, right? They will put salt water, and then you will obtain salt and pure water. You'll put all sorts of weird stuff so you can separate them. Okay? This process is actually called distillation. Okay, next. So there's a heat source in the setup. Explain clearly what happens if this heat source is removed and how this affects the amount of clean water. So if you remove the heat source, yeah, go. If you remove the heat source, what happens? Sing out. What happens when you remove the heat source? Suddenly, okay, I asked Sing Yang, no? Then I said, the rate of evaporation. Because I was looking down, so sound a bit weird. Never mind. Ryan, come. Eh? What you don't know? What happens to the rate of evaporation? Okay, the rate of evaporation decreases. Why?
And the water evaporation needs heat.
Yeah, okay, good. The rate of evaporation decreases because due to the lack of heat source. Okay, so what happens to the amount of clean water? Will decrease or increase? Decrease, right? Alright, this causes the amount of clean water to decrease. Okay? Right? Wow.
That's so short. Mine is
Okay, continue.
yeah, this one we haven't do that.
Haven't do? Do now? Now we do on the spot. Okay, why bell queue did not ring? Where I saw. Okay, who? Richter? How come bell queue never ring?
Because this sentence circuit which did not allow bell to
Which one? Which object?
object
B. Very good, right? So object B is a object B is an electrical insulator. Okay, B is an electrical insulator. So what happens? Does not allow electricity to pass through to bell queue. Right? Insulator. So how will the results be affected if A is replaced by a glass rod? If I change A to a glass rod, none of the bells will ring, correct? Okay, why?
because glass it's not a conductor of electricity. Thus, it will not allow any electric current to flow through, hence no bells will ring.
Yeah. Okay, why? Because glass is an so replacing object A with glass rod. If you replace the object A with glass rod, what happens to the whole circuit? Is it a close or open? Results in an open circuit, and hence no bells, no electricity, and hence electricity cannot flow to the bells. Okay, so there are two things here. It's about the whole thing becomes an open circuit once you put a glass. Second thing is glass. Why it becomes open circuit is because glass is a insulator, electrical insulator. Right? Two ideas you must mention here. Okay, next one. Everyone okay? Any questions?
No.
So far easy? Easy? This prelim question, no?
Also just copying.
But you all understand what's going on, right? Yeah? It's important, right? These are prelim questions, so you can do all this, it's good. Right? Supposed to be difficult. Okay, next. The toy car moved on the plank, stop at W and roll down the plank. Explain clearly this observation.
This kinetic energy got converted to heat energy, thus he would not be able to carry on moving on the slope.
Heat energy.
Heat and sound.
Heat and sound? No. Gravitational force, yeah? Okay, it's about, what else? What other forces are there? Friction, very good. Okay, so friction and gravity. So we will write down. Why did it stop at W? So it stopped at W because, so the toy car stopped at W due to friction and roll down due to gravity. Right? So it's only one mark, not a lot of things to explain. Right, next. So drivers know that it's dangerous to drive too fast on rainy days. Why is a longer braking distance necessary to prevent accident? Do you know what it means by longer braking distance? That means you step the brake earlier. You don't wait until last minute then step the brake. Okay, why? Yes, Pooja.
The water on the road acts as a lubricant, so
Yes.
that the amount of friction between the tires of the car and the road is less.
Yeah.
And so a longer braking distance is necessary to prevent accidents.
Yes, that's right. Okay, so we start from the beginning of the story, right? That means during rainy days, right? The road is wet during rainy days, which decreases the friction between tires and the road. Hence, it takes longer for cars to come to a stop. Okay. Right. So less, you mentioned about acts as a lubricant. Yes, that's correct as well. right? So therefore, you need a longer braking distance. That means you brake earlier. The person has to brake earlier. Don't wait until the last minute. Okay? Before stepping on the brakes. Next. So there's a relationship between the braking distance and the tread pattern. So it's done. Okay? Drawing a line. So this one is done. What it says is that the tread pattern, if the depth is if it's very deep, the braking distance will be shorter. Right? If there's wear and tear, that means the tires has wear and tear, somewhere here, braking distance is longer. Okay, this is drawn already. This is the answer. Alright, next, the last one. Yes. Okay, last one. Parasailing. There are two sources of energy. Identify these sources of energy. Floating parachute. Wait. Energy source, right? They're not asking you about the energy. They're asking you about the energy source. Floating parachutes. Where is the okay? What energy does it have? Floating. Gravitational. Frictional. Okay, can. But why is it friction? Because it's coming down, but the air is propping it up. Okay, because it's coming down. So what type of where does this what's the source of this friction? Air. Very good. Okay. So they're asking about source. This is very tricky. This air. Then how about the speedboat? Where's the energy source? Engine. Yeah, the engine. So fill in the boxes to show the energy conversion as Susie descends and lands after the sport. Okay, first one, suspend in the air. Yep, so first one is gravitation. Gravitational potential. But during actual exam, you're supposed to write the whole thing, right? Then convert to kinetic.
Then the last one S.
Heat plus sound. Yeah. Okay, the last one. How does the speed affect the height of the parachute? How does the speed affect the height of the parachute?
The greater the amount of kinetic energy, the greater the amount of gravitational potential energy.
Okay, do you need to explain here? No need, no. They're just asking you how does the speed affect the height?
So when the boat is going
Faster?
The faster the speed of the boat, the higher the height of the
Yes, correct. That's all. That's all. Relationship, right? So the faster the speed of the boat.
We usually take about the whole lesson.
Yeah. Yeah. So very good. You see, well done. Yeah, improving, right? So the faster the speed of the boat, the higher the height of the parachute. Right? You don't have to explain. Okay? They just ask you. Alright, so we go for a short break, 5 minutes, and we'll be back in 5 minutes.